Hello, my name is Raheem. I would like to present our work, Finite Element Modeling of the Functional Spinal Unit under Compression Loads. First, I would like to explain what is the functional spinal unit. As shown here in this figure, the functional spinal unit, uh, we can explain it here by saying it consists of upper and lower vertebrae within the intervertebral disc between these two vertebrae. The intervertebral disc itself consists of the outer region, which is the annulus fibrosus, and the central part of this disc, which is the nucleus pulposus, as shown here in this figure. The goal of this research is to develop a three-dimensional finite element model to resemble the mechanical behavior of the human intervertebral disc, and to implement the model for disc replacement materials. In this slide, I would like to explain the model, the finite element model here. First of all, the material properties of this model, as shown here in this table from the Shirazi study. Basically, the annulus fibrosus is a complex geometry that contains a composite structure consisting of multiple interlaced fibers with a matrix to encompass the entire structure. However, in this research, a simple structure of annulus fibrosis was modeled to allow for reduced computation. To solve the model, we used ANSYS engineering software to model our lumbar region, the upper and lower vertebrae with the intervertebral disc. As shown here, we divided the model as by elements, and the meshing process was a hexahedral element with a 20 node and other type of elements as shown here in this the intervertebral disc. The outer side here, the annulus fibrosus, and the central part is the nucleus pulposus. The boundary condition, the lower surface of the lower vertebral body here was placed under an Ancaster boundary condition, which essentially fixes the surface from movement, as shown here, three dimension like the displacement in x and y and z direction set as 0. However, the upper part here of this model was placed under axial displacement. In other words, let the model vertically displays in the z direction here, and the ux and the uy set as 0, as shown here in this paragraph. To validate the model, we compared the result from the model with the available literature, such as Joshi study and Shirazi's study. The figure here shows on the x-axis the displacement, the vertical displacement due to the compression load, and on y-axis the applying load here. As shown here, the solid line, the black solid line, the result of this study was in line with the other studies, the Joshi and Shirazi. However, it has been it could be seen here. The Joshi study, this line was a little bit, the response of the intervertebral disc was lower than uh, expected from our study and the Shirazi study. And this could be due to the Joshi study. They used a cadaveric uh, human uh, functional spinal unit, and this maybe was degenerated or because it stayed for a long time. As, a, as overall, we could say our result, like the validation of the model, uh, it, it is a good result which lies within the literature data. And the figure shows here the comparison of the compression response of the model with literature results for intact human spinal disc. That means when the nucleus pulposus uh, was there in the intervertebral disc. As shown here, we have a wide range of the data. This is the Brown data. We have this range, and here the Shirazi and Kolak and Joshi research, and our data uh, was within the range of the literature data. That means we already have validated the response of the model, and the model gives a realistic behavior as the natural one. To examine the sensitivity of the model, the nucleus pulposus was removed. A part of it was removed as shown here in this figure, and by reporting the data from the model, and the model was susceptible for the uh, nucleus pulposus presented, and then annulus fibrosis in the disc at all. And that leads us to include the nucleus pulposus condition, which lead to change the overall mechanical response of the intervertebral disc. In other words, in the future, if you would like to replace the nucleus pulposus of the degenerated disc, we have to have the cavity, the central part of the intervertebral disc, to be filled with the material, and we cannot leave some of the material less, and we cannot give a little material in the central part of the disc. As a result and conclusion from this study, the model was valid to investigate further tests such as torsion and complex loading modes. Additionally, simplification of the model has provided a reasonably accurate set for initial understanding of material behavior. As we said, we assigned the behavior of the disk was as a linear elastic, and we get a result that agrees with other literature data. And finally, the response of the disk is sensitive to the nucleus pulposus condition. Thank you very much.